Recently, I began a mad quest to make thioacetone, the foulest smelling substance on Earth. To do this though, I'll need a way to make hydrogen sulfide. Typically, this is done by mixing an acid with something like iron sulfide, but for me, this method isn't optimal. This is mostly because I would need to make the iron sulfide myself, and I don't have the iron powder to do that, nor the money to buy it. So, I devised an easy, alternative route to generate my hydrogen sulfide that uses common ingredients that you might already have around your own house. For this reaction, we'll need the following reagents: powdered sulfur, sodium hydroxide, aluminum foil, and hydrochloric acid. To start, we add roughly 50 milliliters of common 30% hydrochloric acid to about 3 grams of aluminum foil. In under a minute, the reaction should take off, and it could become quite vigorous. I recommend doing this in a well-ventilated area for obvious reasons. Using cold acid and cooling the reaction in an ice bath might also be a good idea. Soon, the aluminum will be fully dissolved and converted into aluminum trichloride. Some impurities are still present from the aluminum foil though, so I recommend filtering the solution to remove the insoluble junk. Once this is done, we have our Part A solution, which we can set aside for now. Next, we need to make a sodium polysulfide solution. To do this, we add about 10 grams of sodium hydroxide to a small beaker and dissolve it in a small amount of water. Next, roughly 10 grams of sulfur is added to the concentrated solution. As the solution is heated, the sulfur will dissolve and form a dark red solution. This is our sodium polysulfide. So once everything is dissolved, our Part B solution is ready and we can test it out. To test out my new reaction, I added a bit of the Part A solution to a vial and then slowly dripped in some of the Part B solution. Immediately, we can see a white precipitate form and hydrogen sulfide bubble out of solution. So what's happening here? Well, the aluminum trichloride in the Part A solution reacts with the sodium polysulfide in the Part B solution to form aluminum sulfide and sodium chloride. The aluminum sulfide is unstable in water and quickly reacts to form insoluble aluminum oxide and hydrogen sulfide gas, which is our target product. Now you may be asking, why didn't I just add the acid to the sodium polysulfide to get hydrogen sulfide? Well, the reaction to produce sodium polysulfide also produces non-negligible amounts of sodium sulfite. This compound reacts with acids to produce undesirable sulfur dioxide gas, which may interfere with the thioacetone synthesis later on. By reacting the sodium salts with aluminum trichloride, the corresponding aluminum salts were formed. Aluminum sulfite seems fairly stable in water, but aluminum sulfide is not, so the hydrogen sulfide is formed without the unnecessary sulfur dioxide contamination. Pretty neat, right? After confirming that my reaction was viable, I bottled up the solutions and stored them for later use in the thioacetone synthesis. That video should be coming out soon, along with several other cool projects, including a tutorial on Class E single MOSFET Tesla coils. So be sure you're subscribed to my channel. Trust me, you don't want to miss out on the mayhem. And if you want to help support my work, consider donating or becoming my patron on Patreon. The links, as always, are down below. Remember to like and share this video, and I'll catch you next time. LabCoatz out.